So, Node.js, when I teach people, sort of, in the past I've taught people Ruby for their sort of back-end work and JavaScript for the front-end work, and they say, oh, I want to learn Node. Really, there's nothing necessarily to learn to say that you have learnt Node, because it's just JavaScript. There's really nothing special. It's one of the sort of primary reasons why the developers of Node created it was because they thought, well, if we're all using this language to build all of our front ends, why not use the same language to build our back ends as well? So it is just JavaScript. So all of the syntax and the features of the JavaScript language are available in Node. So it's JavaScript, but it's not in the browser, and that's pretty much it. It's fast, and it's actually fast because it can't do multi-threading. So multi-threading is when you have sort of lots of different things going on at the same time. And now you might be thinking, well, we've got asynchronous JavaScript, we've got promises, we've got set timeout, we can do lots of different things at the same time. Actually, you're not actually doing that. We'll kind of talk about that a little bit next, but you're still working through one, or JavaScript, the engine that's running JavaScript is still working through one single list of tasks. Other languages can do multiple lists of tasks, but actually it's in JavaScript's favor because it allows you to create super fast servers that just have kind of one job. It's very lightweight, so I really like to build sort of small node-based tools for my job or for colleagues of mine, because it's really kind of nice just to get something up and running very easily. Other sort of frameworks require quite a lot of setup, and you end up with sort of 100 files in your directory that you don't really need. But to just spin up a pretty simple Node tool, you just need a couple of JavaScript files and you're away. So of course another pro is it's the same language as the front end, so you get that sort of since Node, the idea of a sort of full stack developer has existed. Previously, you'd be working in sort of C# with .NET or Java or PHP or something on the back end, and maybe you'd do a little bit of JavaScript here and there, but you'd probably have dedicated back-end engineers and front-end engineers, whereas once Node came along and got very popular, there's no real reason to have that split. If everyone's using the same language, everyone can do a bit of both on the front end and the back end. So a con is that it is the same, but it's different. And it's almost more annoying that that it's so similar to working with JavaScript in the browser, but it is JavaScript in its own kind of, in Node's ecosystem. So where the browser has sort of ways of doing things, Node sometimes does things a little bit differently, and that can be annoying because you're just used to doing it one way, and you kind of think, well, there's no real reason to change it, but tough, you've got to work with what Node gives you. Okay, now this is, if you've ever done any sort of reading about Node, you read any articles like Node.js 101, some kind of introduction, lots of people talk about the event loop. Now, everyone here, or I think everyone here, is pretty much primarily a JavaScript programmer. Maybe some of you wouldn't describe yourselves as that, but you are. Even if you've only done a couple of modules with us so far, you probably could still do most junior jobs. That's the reality. Because you're primarily JavaScript programmers, this idea of the event loop isn't going to be any different. So Chrome actually, it might be different these days, but for a very long time, Chrome actually runs the same engine that sort of computes the JavaScript as Node. So it really is behaving exactly the same way. Other languages don't work in this way, and we'll talk about kind of what exactly it is in a minute. But we felt that we kind of had to touch on it, because if any of you do any sort of reading, I think it's very often mentioned. For a long time, I never really saw the point of mentioning it, but I have recently come to the conclusion that it's I think it's useful to know if you are coming from a Java background or a C# background where things do work a little bit differently. So actually, if you're a JavaScript developer, this isn't particularly news or interesting, but it's always there to give context to people who have experience with other languages. It basically means that code inside a function only runs when it's actually invoked. And so you could define a bunch of functions. Well, this is what we have. We have a bunch of functions being defined. We have this order. We have these four lines down here, 1, all, 3, 2. So we're going to get 1. Then we're going to get this function invoked, which actually invokes 1, 2, 3. So we're then going to get 1, 2, 3 in our console. Then we're going to see 3, 3. Then we're going to see 2. That's really nothing special. That is not or shouldn't be surprising to you. Now, what's happening here is, if I just talked about this single list of tasks, we call the function 1, and the that goes to the top of the list. It then executes that. We call all, which goes to the top of the list, and then it runs that code, which calls 1, which goes to the top of the list and runs that code, and so on. So it has this list that it's constantly adding things onto and then removing them from. Now, in this example, it's just the same, except we have a call to set timeout. So what this now does is it basically adds a task that kind of just gets added to the list in the normal place, but then it's waiting like every tick. It is looking in its list of tasks to see if there are any that have a sort of delay assigned to them, like we do with set timeout, and then it says, okay, that one actually I need to run now, so I'm going to invoke that function now. So if you were coming from a different background, you might think that actually this function gets invoked before 1, all, 3, 2, but it doesn't. It gets added to the queue, but it only gets invoked after the sort of timer has elapsed 1,000 milliseconds. Again, that's all nothing unusual, nothing new to all of you here. Now this is a little bit different. So set timeout 0. So you might think that basically is the same thing as just calling a function. Call this function in 0 time, and then 0 time has immediately elapsed, so it should just immediately invoke the function. But because it is a task with a sort of with a kind of timer associated with it, even though that's 0, this is going to get added to our task list with almost, you can think of it as almost kind of lower priority. So this gets added to the task list with a time associated with it. Node sees that time and goes, all right, I'm gonna keep checking that time, but in the meantime, you can carry on executing your code. So even though we're passing 0, we're gonna see 1, then 1, 2, 3, then 3, then 2, and then 1. We're gonna see it immediately with our eyes, but that 1 call is actually going to happen after the sort of current set of tasks have been executed. So these get added with sort of higher priority. Once all of those are done, it then checks any tasks that have a timer associated with it. So that isn't really how all languages work, and that's kind of why people talk about the event loop. I don't worry if you don't really think like, oh, that's interesting or useful or whatever, because this is pretty much just what you've been doing for the last 6 weeks. This is really not much new, but you do kind of have to talk about it when you talk about Node. So we just touched on it a little bit here. That looks like it's the same slide as before. Yes, but there's an extra line. Just JavaScript, but not in the... Oh, the event loop, buzzword alert, just JavaScript, code inside a function. Okay, that's a bit weird. Right, I think I meant to do that. Anyway, okay, fine. That probably should have been on the previous slide. So asynchronous things and callbacks to happen later, but code inside a function only runs when it's invoked. So you have these immediately invoked functions that get their code executed, but anything asynchronous or callbacks, or I mean, not all callbacks, that can happen later because we have this event loop. It's constantly just running down its list of tasks and seeing if there's anything that it can execute. Okay, the first thing we're going to actually look at and use is the process object. Now, just like in the browser where you have kind of window and document, Node gives you a bunch of global objects. So anything running on a computer is a process, and therefore a Node app or a Node script that is running on a computer is actually being kind of hosted by a process on a processor. So we get access to this global process object, which contains a bunch of information about how Node is running your particular code. Now, here's a link to the process documentation. I do find that the Node documentation is not great. I don't like it if I am trying to Google something related to Node in particular. I will probably try to find a blog post or something on a different site that's just a little bit kind of friendlier. There's, for example, the kind of the search functionality on this site is not great, and there's something about it that for me it doesn't feel super friendly, but it's very comprehensive. It's the official documentation, so it kind of should be part of your kind of arsenal, but do be aware that it's not really the nicest documentation in the world. But process.title, I think for the vast majority of the time, title is probably going to be nothing. Let's see, I would want a sidebar. I would want this table of contents in a sidebar. I think that would make a big difference, actually. PID, so process ID, you can, so all processes on a computer that are running on a processor have unique IDs, so we can find that out. We can find out the platform it's running on. So there's a whole bunch of things we can do with the process, and we're just going to try some stuff out. Specifically, argv. I've only ever really sort of written it, and that apparently that's how I'm going to say it, argv. So in our terminal, we run node index.js to run a JavaScript file using node, then fast, then level greater than 9,000. So we're passing arguments into node that we can get out using process.argv. Process.argv stores an array of the arguments. Now, here's a question. What will be the length of argv when running the above command? So we run node index.js fast level greater than 9,000. Does anyone want to guess how many arguments are going to be listed in the argv array? You're all keeping quiet because you know it's a trick question. I mean, for me, what I would think is 2. That would be my sort of natural assumption, I think, because inside the node script, inside the JavaScript, is node really an argument? Is index.js really an argument? No, because you kind of need both of these to actually get it running. So for me, it's only really these last 2 bits of text which are arguments, and maybe you might have thought 3 if this greater than, maybe that splits it somehow. If you thought 4, that's actually correct. So our array of arguments is actually including node and index.js and fast and level greater than 9,000. It's all just an array of strings. It doesn't do anything to the arguments. We'll come to that a bit later on. But let's play around with the process object. So arguments, and I'm going to, I've forgotten how to open my terminal. So if we run node arguments, and what did I do? I did fast and level over 9,000. Oh. Okay, level equals 9,000. So what that's done is it's taken the output of running arguments fast level and sort of saved the output of that into a file called 9,000. I mean, that's kind of interesting. Console log, I think, hello 9000 level .text. Let's save that into a text file. Hello 900 level. So that isn't really a Node thing. That's a sort of Unix thing, a Mac thing. But that means I'm going to change it from over 9,000 to just equals 9,000, because we don't really want to be making these. So we're just logging stuff out. That's pretty boring. Let's look at process argv. So I'm going to run it again. We get an array. And we actually don't get what we just typed in. So anytime you are running commands in your terminal or your command line, if you run node, you're actually executing a file that is stored somewhere on your computer, and you have an environment variable called path that is saying, okay, when I write node, I actually mean the file stored at user local bin node. And it will be something similar on Windows as well. And the same thing happens with arguments.js, because relative paths, I mean, computers don't really understand relative paths. It's always absolute, but we, due to kind of JavaScript translating stuff for us, we can use relative paths. It actually, behind the scenes, is going to convert it to absolute paths, not always, and we're going to look at that in a bit. But it's taking our node and our arguments.js, converting them to absolute paths, and then we get these two arguments here. So app args is probably what can I do here? This is going to, I can't remember what I've shown to the mod 3ers, the new kids on the block. Is this going to work? I think it probably is. Process.argv. App args. Okay, great. So this is some slightly weird syntax, and I don't think I want to go into it, because I don't think I've really talked to the new kids. I think we need a better name about destructuring. Oh no, maybe we have. Who's on the call? I mean, no one. Daniel, does this make any sense to you at all? Daniel's gone. No, he is here. Absolutely not. Okay, that's good. That's a good answer. So I'm going to keep it in. It's pretty neat, but actually we're going to say app args is an array of argument 2 and argument 3. So it's the same thing. So fast and level equals 9,000. Fast then equals app args.includes fast. So now we have a variable called fast that is going to be a Boolean only if the arguments that we pass to this script includes the fast argument. So fast equals true. Let's get rid of this one. As soon as we remove that, fast is false. So we're kind of constructing an object here. So So we could say args equals this object. Fast is the result of this. Maybe that's a bit overkill. So app args includes fast, and level equals, let's create a function. Level equals level arg, or args level from args. Args. Okay, so we're going to call that level from args. We're going to pass in app args. So this is going to take our array of fast and level equals 9,000. If no, let's do find. So level argument equals args. It's an array of strings. So each individual arg, we want to say, does it include level equals? And if so, if level argument, if we found something, then do something with it, else we're just going to return 1. By default, the level is going to be set to 1 if the user doesn't specify anything. So here, split is level argument dot split, then return pass int split 1. That will do. And we're not logging it out. So there's the level 9,000. Now, as a user, I actually want it to be level 100, and I want it to be slow, but now I've decided I want it to be fast, and it's now fast, true, and level 100. So this is all just using the process global object that is available to us. Let's have a look at what that actually looks like. There's all sorts of information in here. There is loads. The vast majority of the time, you're not going to need almost any of this, really. But what could be interesting? So platform. I mean, it's not going to be very interesting just running it on mine here, because it's not going to change. But if you did the same, you will probably get a different platform if you are using Windows or Linux or anything like that. Process.main module, that is describing the file, the JavaScript file, where it is, and kind of why is it doing this? Node, path, right. Yeah, Node basically, it has a bunch of places that it tries to find your module, and I didn't really realize this, but they're all kind of defined here, which is quite interesting. Process, arg0 is always node, title is node, most of these, so user, process dot, that's what I wanted to show you, env. So your environment variables that you can specify in all sorts of different ways, but environment variables are often used to store kind of secret keys on a server, for example. So you write your node code, you write your node server, it's using some secret keys to kind of encrypt all of the data. you don't want to include that secret key on GitHub. So you can specify on the server itself that it's storing a bunch of environment variables, and then you'd say process.env my secret key, and then yes, it's going to be undefined here. But let's see if there's anything that I recognize that I've actually added. I mean, there's probably a secret key that I actually have created and probably don't want to be showing on this video. But RVM stored NVM directory. Nah, this is all not particularly useful. But process.env environment is certainly very useful later on when we look at Webpack and other sort of JavaScript tools. So that's definitely something you want to be aware of. I don't really think there's much else in the process. So we'll move on to the next bit. I don't think there's a questions section because process is not particularly exciting. And require, again, you should all be pretty familiar with require because you've written Node apps before. Node uses modules. That's what that's the kind of name that Node uses for libraries. The sort of generic term for most languages is a library. But Node kind of calls them modules. They are just files. They're files that specify that they export some data. Require, the function, again, it's a global function. We don't need to require the function require, but it loads up the content of the module, it executes the code in there, and it figures out what that file is exporting, and then it gives it to you as whatever data that file is exporting. So it can take a path or a package name. A package name as defined using npm or yarn or anything like that. So if you want to install extra modules, which you certainly will want to do, you can require them just in the same way as you require built-in modules. So we don't have to specify that we want to install FS because FS is a built-in module for Node. We have to specify that we want this app to use FS, but we don't have to add it to our package JSON or run npm install fs. It's already there, but we want to say, hey Node, give me your fs package. Whereas Lodash is a sort of installed third-party package, but we don't have to say that we don't have to have a path to the file name. If we've installed it correctly, Node kind of treats it like a built-in module, and it just loads up whatever Lodash has defined to give you and stores it in this variable. Okay, that's require. You all know require. Now FS, I don't know if in module 1 we talked about FS. The project certainly was using it, but actually it was all sort of abstracted behind an API library. But if you want to go back and look at that, that API library is using FS to read and write JSON files, I think. So FS stands for file system. So anytime you want to access files on the computer on which the Node app is running, you need to use the FS module. So yeah, anytime you want to read and write, there are 3 different ways that you can use file system, and that's quite annoying. I don't like that. I appreciate that they're giving flexibility, but I would prefer that they just stick with one way. We're going to look at all 3. I think generally you want to be using either the callbacks pattern or the promises pattern. Using the synchronous blocking pattern is not a great idea, but if you kind of know that everything's gonna stay relatively small, and you're handling the chance of it going wrong, then you should be okay. So the first function we'll look at is read file. Funnily enough, it reads a file. So we've got a file called memes.txt in this folder. In the folder, possibly the same as index.js or that JavaScript file that we're running. So it's a relative path, it takes a string, and the second argument is a callback. A callback which gets invoked when fs has finished reading the data inside that file. So that's fairly straightforward. Now, the arguments that callback receives, it is always an error object first, and then the data that was included. If everything worked, the error object will actually be, I think it's null. It's not undefined, I think it's null. It passes you a null value. So if everything's worked, the first argument you get in this callback will be null, and the second argument will be an object or a string, or in fact, I think it will kind of always be a string, possibly not. But quite often you're going to see something like this. This is a sort of simple, clear example. If error, so if it is truthy, if there is an object, if there's something that describes what went wrong, then console.error whoops and the error. Else, we are assuming we've successfully got that data because there was no error. So log out a message data with that data. So we're now gonna use read file, possibly write file if I keep an eye on the time, with each of those 3 ways: callback, sync, and a promise. Okay, files. So we want to require file system, and let's just look at it first. Node files. Append file, can't remember what that does. I think it's adding data onto an existing file, I think. Access, change ownership, I think, change mode, close, copy file. So some of these are reasonably sensibly named, but quite a lot of them I definitely have to kind of look up the documentation to really figure out what you actually use it for. Read directory, read file, read link, stat. I've certainly used stat before, can't remember what it does. Unlink, we'll look at that, and write file and write file sync, we'll look at those. So there's quite a lot in here, and you probably won't be using all of it. So what did we say first? Callback, then sync, then promise. So let's say memes path is memes.txt. So we're going to load up this file that is stored at memes.txt. So file system dot read file. We pass it memes path. It's going to always receive an error first, then the data, and if there's no error, that error is actually null. So if there is an error, console.error error, else console.log data. We want to actually see that data. So let's run it again. Error, no such file or directory, open memes.txt with an object with some kind of information about that error. So because that file doesn't exist, we get an error, so you'd want to kind of throw an error. Throw error. And throw is a little bit like return in that it stops code execution. It's kind of gracefully allowing an error to occur as long as it's being caught somewhere else. So very often when you read not only file system documentation but node documentation generally, this pattern of having a callback that may or may not receive an error is pretty common. So you want to kind of get used to this pattern of initially, if there's an error, throw the error, and somewhere else we'll catch it. So here it has actually shown us some information about where that error occurred. In this one, console.error, it's like that just displays it. In this terminal, it doesn't even display it differently. In Chrome, it displays it in red. But by throwing the error, Node has said, all right, something's gone wrong. I'm going to try to help you. I'm going to show you where it is. So it's always good practice to throw the error rather than just sort of log it out. But if we create the memes.txt file and php google.com/funnymemes, that's probably a URL. Okay, console log data. That is now showing a buffer. A buffer is like the sort of raw data that is stored in this text file. So even though you think a sort of text file is as basic as it can get, it's still just sort of binary bits on some magnet somewhere in this computer. So a buffer is the sort of rawest version of a file. Therefore, there is another way that we can call read file, and I was hoping that it would come up with different. Anyway, so I think I'm just going to guess I get this wrong. The second argument. Okay, yeah, good. The second argument is specifying the encoding of that data. So UTF-8 is kind of a standard way to encode text files. So we're telling file system that we're basically telling it that it is text and that it is encoded using UTF-8. So now Node already converts it from the raw binary data into UTF-8 encoded text. So when we log out data, it actually displays the funny memes 1, 2, 3, whatever. It displays the content of that file. Okay, so that's using the sort of standard read file function. Now, many, I don't think all of them, but many file system functions have an equivalent sync version. So read file has an equivalent read file sync. So this time we can pass memes path and UTF-8, and it doesn't take a callback. It data, it actually just returns the data back to us. So console.log data, let's do data sync. Okay, so data sync has actually come out first because of the event loop and that single list of tasks. Because this is blocking, it actually, even though we call this function first, Node kind of goes, okay, you've told me to read this file and you've given me this code to execute when I've finished reading the file, but because it's using a callback, because it's built in such a way that it can just keep going to the next line, it then moves on to this line, it calls read file sync, but read file sync is blocking. It doesn't take that callback, it doesn't do anything in the background, it's not asynchronous, it is synchronous. Therefore, it just hangs on this line until that data has been read, and then eventually it moves on to the next line. So, okay, this is 5 lines long, it's a very small file, but if that was a much bigger file, your entire app would just hang on this line until the Node app has loaded up your sort of 100 terabyte of data or whatever. So using read file sync or any of the sync functions, really, it's not a great idea. I mean, if you probably find almost any Node app I've written, I certainly use the sync functions all over the place, because sometimes it kind of just reads nicer. You don't have to faff with a callback. It's slightly annoying, but it's much better practice to be consistent, use callbacks or promises. So FS actually has FSP has an equivalent object kind of embedded into the wider FS that is at the key promises. That was a slightly weird way to put it, but let's look at what FSP actually is. Copy file, open, read directory, unlink, write file, read file. So these are all of the same functions that we're using up here. Okay, we're only using one, but fs.opendirectory, fs.link. They are just the same names, but the difference is they use promises instead of callbacks. So fsp.readFile memes path UTF-8. So we pass the same things here, but this time we can use the promise syntax of data console log. Promise data, and in this case we can catch it. So error, throw error, just console.error, error. I'm going to do a format. Okay, so that to me reads nicely. I prefer that over this sort of thing. Then you can go one step further. I don't know. I can't remember if we've talked about async await with the new kids. Or in fact, I can't remember if we've even talked about promises. I'm clearly incredibly forgetful at the moment. But if you wanted you have to do the silly thing where you wrap it in an async function, but data is await fsp.readFile memes path UTF-8. So on the next line we have data, and then we can invoke that. Now this is the best of both worlds. This is probably one of the neatest ones, but it's blocking. It blocks all the rest of your code. The benefit of using a promise and then the async await syntax for a promise is that you get this nice flow of, on this line do this, and the data that this function returns is going to be stored in this variable, and we're going to wait for it to return, and then we're going to move on to the next line. But all of this is going to happen while everything else is still continuing to go on. So if promises and async await and stuff, if all of that is still confusing, then that's fine. The sort of standard Node way seems to be callbacks. I certainly prefer promises, but I've used promises for a long time and I like them. There's no right answer here, really. So we're loading up memes text. I think that's all I want to show you now. Any questions so far? Mushtaq says, no, we didn't. Promises and async. Yeah, okay, that I sort of realised that slightly late, but never mind. We can talk about that another day. I think, so right, I'm kind of remembering now. Module 2, all about front end getting websites to be interactive, but we deliberately didn't introduce requests and asynchronous and promise and stuff until module 3, that is now 4. So don't worry about that. We'll come to that at a later date. Florence asks, did I use the REST operator? Yeah. That is up here. So for those of you who kind of have an idea of what's going on here, we're destructuring the argv array, and where you normally destructure, and I mean not necessarily normally, but you kind of destructure, you take the first argument out and you call that some variable. If you don't actually want that, but you kind of want some others and you want to skip it, you can basically put a comma in place, or you kind of just don't give it a name. So we don't give that first one a name, we don't give that second one a name, and then we take the rest of the values in the array and store them in a variable called app_args. So in this case, we skip the first two and take the remaining two, but if there were 10, we'd skip the first two and we take the remaining 8 into a new array. Again, if we haven't looked at, oh, Mushtaq thought this was going to be React. What? No, I don't think so. Module 3, Node. Module 5 is React. You're 6 weeks early, I think. No, 8, 9. I don't know how many weeks. You're quite early with React. Yeah, okay. That threw me slightly, but yes, Florence, you're correct. That's the rest operator, and everyone else will cover that at a later date. Okay. Another one that that you'll use probably pretty often in a way. Anytime you're loading up files, you should be also using the path module, because using paths to files can go wrong pretty easily. So you remember when we looked at the arguments that Node translates your arguments into, you just write Node, but it translates it into an absolute path. That's pretty much, there's like 2 or 3 others maybe that I've used, but pretty much 95% of the time I've used the path module. It's to use path.resolve, and it basically turns a relative path into an absolute path. So in this case, we'd want to say, okay, create a variable, it's just going to be a string. We're going to call path.resolve and give it that relative path that we had previously, and it's going to give us an absolute path, and we're going to pass that through to read file. So I'm going to demonstrate, or try to demonstrate, why you do things like this. So let's create a new directory, temp, good old temp, cd into temp, and then if we run node files from out there, yes, great, it did work. Or it didn't work, but that's intentional. So we are inside the temp directory, but we're running back one, so out into this directory, files. But even though this file is created and lives inside the sort of root directory, because we're running it from inside the temp directory, that means it's actually looking for a path relative to the temp directory. So if we say, if we want to require path relative memes path, then we create memes path, path.resolve. And I can't quite remember exactly how we do this. So I think we go to process dot Yeah. CWD like that? I can't remember exactly. Let's see what happens. Process.cwd. CWD stands for current working directory. So let's log these out. Let's just see what this looks like. Process.cwd and then relative memes path. So current working directory is this temp directory, and then relative memes path is this sort of relative to this file. So actually, I think we want to do PWD, which I think is process dot. What's exec path? I can't remember. Let's see what it is. It's the same thing. Oh no. Use, all right, that's node. So meme location, yeah, okay, path.resolve. I even did this one wrong. Process. So in here, we want to look for path.resolve. So it takes a variable number of arguments and sort of joins them all up. So what we actually want is the current directory of the JavaScript file that is being executed, which actually is probably on process pwd process env pwd. No, that's still the temp directory. Oh, I can't remember. Okay, I can't remember. I give up. It's not that important. Path resolve. Okay, I don't know. I give up. So if we run node back1 files that no longer exists, run node files, then we don't want exec path. We want current working directory. That's going to annoy me, and I will look it up after. But okay, we're loading up all those files. We're using a path that's resolved. I mean, one benefit of doing it like this is that you don't have to kind of hard code anything. You don't have to rely on things being in the sort of same place. So it will calculate a kind of absolute path from the arguments that you pass to it. Okay, we're now going to take all of that and build a to-do list. So it's going to be a little CLI that takes arguments. I think in module 1 you possibly did something like this, but you used I can't remember what it's called, but probably like one of the libraries to help you display options and give a pretty nice interface to a user. But we're going to do things a bit differently now. We're going to take arguments to create new tasks, view tasks, complete tasks, and we're going to keep saving it to a file. So, not in temp, todo.js. Okay, we want to load up file system. We want to load up path. I think that's it. We want to get our arguments, so let's take app args, which actually I don't like this. I think we're gonna go for the fancy spread operator thing. So we're going to destructure our larger array of arguments, get rid of the first two, and take all the rest of them into an array called app arguments. So app args, let's log it out. Node to do, we're going to run to do, and what are we going to do first? So we're going to say create by milk. Let's see what we get. Okay, so we get an array of two things. We have the first argument is create, which could be our sort of action, and our second argument is some kind of detail about it, possibly. If we say create equals by milk, it all gets shoved into one argument or one element in the array. So for now, let's keep it as, let's require our users to pass first an action and then a kind of argument for a function maybe. So let's say create is app args.includes create, and do the same for view. So if it's view tasks, then we want to view them all. If it's create, then we want to create one. If view show tasks, if create task, and complete. So done could be our complete action. If done, we could pass maybe done by milk. It's not going to be the nicest, most user-friendly to-do list in the world, but we can say done by milk, and therefore we're going to mark the task that is done by milk, as done. So console.log mark task as done. Done. Okay, so that's sort of a bunch of stubbed out code. Mark task is done. View and create. We create up here. Okay, that looks all right. So now let's deal with the loading of a file that has some to-do list data in it, and writing to that file as well. So let's create a file called to-do. Why not? VS Code quite likes this for some reason. It's got a little checkbox. Maybe there's a special syntax that we should use for a to-do file. Maybe not. I don't know of it. So I think what we could do is have by milk, then a sort of double colon type system to sort of split the title and the incomplete, the sort of status. So by milk is incomplete, but by by serial is complete. So we're going to load this file up. We're going to take the data in this slightly weird format and convert it into something useful in our code. So we want a to-do list that looks like this. Task is buy milk, completed, false. So that's what we want to end up with. So I'll comment that out for now. So we're going to have a function, get to do or pop you late to do list. That'll do. Or get to do. Let's say get to do list. We're going to return the to do list. So first we want to get the file. So read file to do, no file extension or anything. UTF-8. We have the error object and we have the data. So console log data. Let's have a look at what that is like. Then to do list equals get to do list console log to do list. So we've got undefined here, then we've got create task, then we've got buy milk incomplete and buy cereal incomplete. So something's undefined. It is to-do list. This function isn't returning anything. We're then trying to sort of create a task because we're coming down here. But after all of that has happened, we are actually logging out the data after we have got the to-do list from the file. So let's deal with that first. The data is on Mac, on Unix, it doesn't actually show you. I'm sure you can change the settings, but it doesn't show you the line endings. But at the end of each line, can we show render white space? Okay, it's not really rendering the white space though, is it? Yeah, why isn't it? Render control characters? Anyway, okay, that doesn't work. So I was expecting, if render whitespace was on, to see like a little return arrow at the end of this line, because there is a character at the end of the line to tell your computer to display it on multiple lines. It is a special character that needs to be escaped. So in our string, we're not actually just looking for a string that is \n. We're looking for a special character that is a new line, and this is how we write these special characters. A backslash before a sort of letter or some kind of character denotes that it's a special character. This time we get an array. We have split by new line. We have all of our tasks on each new line. So lines is data.split. Then we can create tasks by mapping over each line, and we're going to return an object that has completed set to line.includes colon complete. Let's do that. So this gives you a Boolean. If the line includes colon complete, that means that task is completed. And we also want, what did I say, the task? The task is going to be line.split space colon. I mean, it doesn't really matter. 0, it's not great, but never mind. So we're iterating over each string, we're splitting that, we're checking if it includes this complete thing, and we end up with an array of tasks. Task by milk, completed false, completed true. So now, do we just return tasks, and then maybe we return file system read file? We still get undefined here because read file returns undefined. There's nothing that it can return to us here because it handles the data inside this callback. So the only way for us to kind of get access after our processor has loaded up the data is to then pass a callback, sometimes sort of referred to as done. So done, and we pass in the tasks. We say get to-do list, and then in here we move all of this code and we receive the to-do list as an argument to the callback. Now, that is sort of fine. We're starting to pass callbacks through to other callbacks. Promises and async await were invented to kind of reduce callback hell, which is a phrase when there are too many callbacks. So it's not, you get confused very quickly with too many callbacks. But I'm going to leave it like this for now. Partly because half of you don't know anything about promises yet. So we call that function, we pass it a callback. When it's done reading all the data, it calls our callback, and then we have our to-do list, and we can either view them, or we can create a new task, or we can mark a task as done. So here, console log, what can we do? To-do list dot map task. We say task is task.task. Oh, I don't like that. Then task.completed. There's probably some sort of special character for a tick and a cross, but I can't be bothered to find them. So completed, yes, no. So now we can run, not that. We can run view. I don't want to see that. Or we can split, join with our special character to backslash. Okay, lovely. That'll do. We're viewing some tasks pretty nicely. Now we want to create something. In both of these, we now want to write to a file. So here, where we are calling get to-do list, which calls read file, we're now going to say create new task. new task, which is going to be the string. So what we're doing up here is create by milk. That is going to be the task property of a task, and we want to convert the new task into a file line, a kind of new line to be inserted into the file. So that would be new interpolated new task. It starts off as incomplete. There's no point adding an already completed item to a to-do list. Then file system write file to do. Then we can say file line, create new task, mark task as done. What am I doing? Create new task, and then app args let's just say no, what it'll be 1. It's not great, but never mind. Invalid callback. Callback must be a function. Oh, right. So we're writing now, aren't we? So when we call write file, we need to give it a path, we need to give it some data, and then we give it a callback that receives an error and the data. So console.port if error throw error. Otherwise, we want to see that data, or we can just log out something like done. Okay, done, undefined, okay, fine, we actually don't get any data. All right, so let's view the tasks again. There is just by milk. So write file, as maybe you guessed, it actually overwrites, it sets the data in that file to whatever you pass as that second argument. So I don't think I've used it, but file system, actually yeah, I probably have. .append I saw somewhere. Asynchronously append data to a file, creating the file if it does not yet exist. Ooh, that's very good. So append file, it will, I mean, I didn't look, but there's no reason why they would change it. So yeah, it takes a path to a file, the data to add to the file, and then the callback. So it's pretty much the same. Create by milk, create by cereal. So now we have 2 on one line. I think we probably append file sync. Oh, okay, I know how we can do this. We want them split on new lines, so we could do it here. Yeah, let's do it here. So let's chuck on a new line character at the end of our new line. So we're going to create by serial again. No, literally the opposite. I always do that wrong. So doesn't really matter, but for me, this makes a little bit more sense in my head. This variable called file line should be sort of just the new line of data. And then here, where we're adding it, where we're appending it, let's actually chuck on a new line before that. However, I've just realized it doesn't really matter because whatever. Great. Yeah, because of that, exactly. That's so because this one didn't have a new line, it adds it here, but if everything is adding a new line at the end, which is how it actually should work, or we can do it there, then they're all going to go one after the other. So we can create by milk, and you can see there is already a kind of empty new line ready for the by cereal, and now there. Okay, so my first idea was actually correct. Right now, it's 7:34. That's probably plenty of time. Now we're going to mark the task as done. So set task as completed. It's going to be a function. Again, we're going to pass in app args. Then set, what did I say? Set task as completed. Task. Okay, so we want to get the to-do list again. We then want to change, well, we want to find the appropriate task. We want to mark it as complete, and then we want to save the file again with the new data. So we want to read to-do list, find existing task, set task as complete, save file. Okay, so get to-do list is the function that we had up at the top that takes our callback. I don't quite want to. Actually, no. Yeah, I will. No. No. Let's keep it like this. So to-do list is going to be passed through to this callback. So all of these then move up into there. We find the existing task. So task is to-do list dot find task. We want to find the task where task equals task. And I've probably changed between task and task several times today. Sorry, that's my strange upbringing. We then want to set the task as completed. Then we want to save the file. So here we are appending it. We now want to overwrite it. We've got all the data out. We want to just change that one bit, and so we kind of take everything, change what we need to, and then put it back in its sort of original format. So tasks as text. So we now iterate back over the to-do list, and we take each task and we return a string that contains task.task, a space, a colon, and task.completed, or what is it? Complete, incomplete, complete, or incomplete. So all of those tasks are as text. We then can join them with a new line. Actually, no. Let's do this, and then join them with nothing. The reason I did that is because using join adds the join in between all of them, but we do actually want one at the end. So each line here is going to have one at the end, and we join them up with no characters. So we've got that task, those tasks as text. Finally, we want to write. So write file to do and tasks as text. Error if there was some kind of error. Then we throw the error. Otherwise, done setting task as completed. So now, done by serial, done setting task as completed. We can view it again, and that looks wrong, but let's ignore it. Or shall we ignore it? Task.task, task. I think that's, there are too many tasks. Maybe not actually. Task.task is task. It's very confusing. Okay, I'm doing something wrong. By milk incomplete, by cereal complete. Then I did done by cereal. What's wrong with that? Anyway, doesn't really matter. That's not the important part. The important part is getting used to reading and writing from files. It's something that I do a lot. You don't necessarily do it if you're building kind of typical web backends, but the types of things that I build are sort of file handlers. So a tool to kind of compress a load of images or something like that. So you'll receive those files from the user, you save them onto your machine somewhere, you kind of run them through some processing script, and then you will move them into the final destination on the server. So that sort of thing I tend to do quite a lot. Mushtak says too many tasks. It's true, there's always too many tasks. And I think I'm sure you have literally dozens of questions, but I think I'm going to skip even asking if there are any questions. If there are some, please chuck them in the chat. There's a few more bits to cover that are slightly more important. So this Yargs package, Vasil really likes this Yargs package. I think that I'm sure there are tons of packages out there to help you with arguments, but doing this, if you not, well, I suppose that bit was fine. It's this bit, and that's not very nice, especially if you have anything more complicated than this. It is really fairly straightforward, this, but Yargs is a pretty nice package. Yargs to help, and it's pirate themed as well, to help handle arguments. So here's an example. We receive an object, we destructure argv out of the object. Why do I want to, wow, oh, this is a new GitHub thing, that's nice. Wow. Okay. So here we're using the sort of double hyphen or the hyphenated with the single hyphen. There is a sort of common syntax for arguments, passing arguments to scripts that you're running, and it's Yargs supports both. So --ships equals 4. argv.ships actually just gets already passed into an integer as well, or we can have --ships space 12, which will give us argv.ships is 12. Maybe I actually won't even do the refactoring. It's not really worth it. But you always want to kind of do it the hard way, or do the first few steps the hard way before you go and rely on some third-party library that does make your life so much easier, but it will certainly help in the long run if you play around with the raw array. Oh god. The raw array of arguments that come through. Okay, I'm not going to refactor because we're running out of time. And this is really the important one, but it's kind of, we're going to do it fairly quickly because we're going to cover it much more because this is what Node is used for primarily. It is for building servers, for building backends for websites in JavaScript. So it has a built-in package called HTTP. HTTP is the protocol that requests and responses use in browsers and I mean, just to send data over the internet. That's what it uses. So the Node package to use HTTP, the HTTP protocol is called HTTP. It uses requests and responses. Now, those of you, the old folk here, will probably be familiar with requests and responses. I don't think the new ones will so much. But basically, every time you try to get some information or some website or data or anything from a URL, that's you making a request. The server receives that request, figures out how it wants to respond, and then sends a response back. There is a request-response cycle. With HTTP, you can only receive a response from the server if you have made an equivalent request before it. Later on in a few weeks, we'll talk about another protocol where that's not the case. You can send as many messages back and forth as you want, and that's very nice and cool and modern, but the vast majority of requests that are made are HTTP requests still. Okay, so the library module, HTTP has a function called create server. We pass a callback called handle request callback. We can name it whatever we want, but I'm being descriptive. It's a callback to handle a request. It's called every time a request comes in. It receives a request object and a response object. So first argument is request, second argument is response. Very often you will see them shortened to rec and res, REQ and RES. Unsurprisingly, request includes information about the request, response includes functions to change the response before sending. So remember, a server, an HTTP server, receives a request, figures out what it wants to do with the response, then it sends the response. So our response object includes a bunch of functions to figure out what we want to do, and then a function to send it. So here is our handle request callback. Every single request that is made to our server comes through this one function. We receive a request and a response object. If request.url, if the user is trying to make a request to google.com and somehow we are building Google's server, I think that even that's for esteemed graduates of Coders in Hoods, I think that's fairly a lofty aim. But if the request URL is google.com, then we write to our response body, we write some data, in this case a string, enter your search term, else we don't have that, you're looking for Bing, not Google, and we only deal with Google, so we're just going to say 404 not found. So you call the function write to kind of populate the body, then you call response.end to actually send the response back to the server. So in this bit, you're figuring out, you're setting headers, you're setting a status, you're writing to the body, and then at the bottom of the function, you finally call end to actually respond to the user and send that response on. That's the last slide. Okay, so let's build a little server. So we require the built-in HTTP module. We have a server and http.createServer. Handle request is going to be a function that we have up here. And then we want to start add listener. Listen, there it is. And so we call the function listen, we pass it a port, so any kind of traffic going in and out of your network on your computer goes through a different port. So I don't know, 5, 6, 7, 8. Isn't that the first lines of like Cotton Eye Joe or something? Node server JS. So notice how that every other time we have logged something out or whatever, and we have access to the terminal again. But this time we don't. It's sort of like terminal blocking, whereas the sync functions were code blocking. This server has now said, like, I'm going to be listening forever. I don't want this process to ever stop running. So by calling listen, we are now listening at port 5678, so localhost 5678, and this is exactly what I expect to see. Open a new tab. Yeah, that's a bit better because we don't have all that other stuff. A timeout or just like a failed to respond. I don't know exactly what it's going to say, but our server isn't sending anything back. So this function, response console.log, I had a request, response.send, done. Let's restart the server. response.send is not a function because it's end. Now we've built our very own web server. If we want that to look nice, chuck an H2 in it and restart the server. That's very annoying. Now, okay. We have to say HTML. Restart the server. I've shown some of you NodeMon. Okay, there we go. Look, doesn't that look great? So we've built a web server. We're serving some actual HTML. This, at the moment, we couldn't just load up a CSS file next to it or a JavaScript file because our server isn't set up to serve static files. That's what that is known as. But there's no real reason why we couldn't do that. So if you want to see the to-do list, well, first let's actually look at the request. So I had a request, and again, there's loads of things in here. Request dot URL. Haha, favicon. That's an annoying thing, but URL. I had a request at just slash. If we go to slash, what was it, memes, we can see that we get slash memes. So if request.url is slash memes, then inside here we can do our file system read stuff. So require file system dot read file. I want to read memes.text. It's UTF-8 encoded. Was there an error? What is the data? If there was an error, we want to say response.end. Oops. Else response.end data. So nothing's different because we're always hitting this. So if the request URL is memes read file, because this is asynchronous, we're waiting until later on to actually call response end here. So we're always calling this. So one solution to have an early return inside this if statement, so it doesn't ever get to this response end line. Now we can reload and we can get funny memes. And that, if you kind of extrapolate slightly, you could now build an entirely sort of Node backend server-based to-do app. You don't need JavaScript on the front end. You can have like if else, if request URL is new task, then return that, and then response, and then done, like an input field. Suddenly there's an input field. Suddenly you've got a form with an input field. You have an input type submit. Okay, there's an extra caret in there, but now we hit submit. New task is not quite the same because it's slightly different, but if you just keep extrapolating, you can build an app just using this one file, just using these two modules, and it's really not that complicated. To build anything other than pretty simple stuff, doing it this way using the HTTP module, it becomes a little bit tedious. Everything's going through this function. It's of course you have other functions, but that's why there is a library called Express that is really the sort of standard Node server library, which is what we're going to be looking at on Thursday, I think. So that's a pretty kind of whirlwind tour of sort of a bunch of Node features, many of which you already knew about. Node is, like I said earlier, it's just JavaScript, but it's actually, when you say like I know Node, actually it just means you're familiar with Express. You're familiar with some libraries that are very commonly used. So on Thursday, I think we're going to be looking at Express. We're going to be building another server, and yeah. Does anyone have any questions? Mushtaq says, does this work similar to live server? No. Oh, do you mean NodeMon or NodeDemon? That sort of does, yeah. Yeah, so it sort of looks at your JavaScript files and reloads the node process every time it changes. Any questions from anyone? Okay, that's a no. Thanks very much. I've moved, so I don't have